Hello. How much do you really know about quantum mechanics? Particles can exist in multiple places at once. Reality is determined when we observe it. We live in a world of probability. Sound familiar? You've probably come across these ideas in school or popular science documentaries. And more often than not, they're presented under the label of the Copenhagen interpretation. This interpretation is often treated as the default, even the only valid explanation of quantum mechanics. But here's a fundamental question we should be asking. Is that really true? Is the Copenhagen interpretation truly the consensus among scientists? Let's take a closer look at what physicists themselves actually believe. First, let's briefly recall what the Copenhagen interpretation says. Formulated in the 1920s by Niels Bohr and Werner Heisenberg, it claims that particles exist in a probabilistic state until observed, at which point they collapse into one definite outcome. For example, an electron creates an interference pattern as if it passes through both slits at once, but when observed, it appears to pass through only one. Many people take this as the quantum theory. But in fact, among physicists, opinions are deeply divided. Let's look at a real example. In 1999, a major international conference on quantum physics was held at the University of Cambridge. 90 respected physicists attended. During the meeting, a simple survey was conducted. Which interpretation of quantum mechanics do you support? The results were surprising. Only 4 physicists supported the Copenhagen interpretation. That's less than 5% of the group. In contrast, 30 supported the many worlds interpretation, which says every possible outcome actually occurs in a branching multiverse. And more than 50 participants abstained or withheld judgment. So the interpretation we often teach as standard was actually a minority view among experts. Did things change over time? Let's fast forward to 2013, when another international conference was held in Austria. This time, 33 leading researchers in quantum information theory were surveyed. The Copenhagen interpretation received 42% support, the highest among the options. But still, not a majority. The information theoretic interpretation got 24%, and the many worlds interpretation received 18%. Others remained undecided or supported alternative views. What does this tell us? Even after more than a century, there is still no consensus among physicists about how to interpret quantum mechanics. The math works flawlessly, but what it means is still up for debate. Why are physicists so divided? The reason is simple. Quantum interpretations are not testable scientific claims. They are philosophical frameworks for explaining the same mathematical results. The Copenhagen view focuses on probability and observation. The many worlds view assumes all possibilities actually happen. The information theoretic approach treats the quantum state not as reality itself, but as our knowledge of reality. They all use the same equations, but they offer radically different views of what is real. In fact, even a Nobel Prize-winning physicist has expressed serious concern. Gerard Hooft, who won the 1999 Nobel Prize in Physics, has openly criticized the current state of quantum theory. He said, "Quantum mechanics is fundamentally vague and incomplete. We are good at manipulating its equations, but we don't really know what they mean." This isn't just a philosophical quibble. It touches the core of science itself. What kind of world do we actually live in? So here's what you need to know. The interpretation of quantum mechanics found in textbooks, documentaries, and popular science books is neither absolute truth nor scientific consensus. It's just the first framework that gained widespread acceptance, and many people assume it's the only one that exists. But even now, scientists around the world are actively debating what quantum mechanics really tells us. No interpretation has been universally accepted. Science is not about declaring final truths. It's about questioning, doubting, and breaking the old frames when necessary. The fact that quantum mechanics is still unfinished is not a failure. It's the very reason we must keep thinking. The Copenhagen interpretation is not the answer. And that's exactly what makes science exciting.